In this video, we're going to take a look at hole and thread and chamfer notes inside of our Inventor drawings. So here I have the hole and thread notes DWG from our working files directory. On our Annotate tab, on the Feature Notes panel, we have the hole and thread command and the chamfer command, which we are going to be investigating. I'll start with the hole and thread command. With this tool, we can select on different circular edges and it will return to us the information about that hole from our modeling environment. So when I create a hole in the modeling environment, whether it's a clearance hole, a threaded hole, an MPT threaded hole, a counter bore, a countersink, that information stays with the model so that when I come here to this environment, it extracts that information into a hole note for me. As an example, when I zoom into this hole here, which has threading on it, and I select the threaded edge or the curved edge, either one, it will give me the information about that hole. Likewise, on holes that do not have threading, it will also return that information as well. To modify a hole note, you can simply right-click on it, and you have an option to add text or edit the hole note. If I choose the Edit Hole Note option, it will bring up this hole note dialog box. Inside of this box, we have the ability to change what information shows up from the hole note, as well as different options such as the default settings, to use the tap drill, part units, precision and tolerance adjustments, such as turning on individual tolerances for primary and alternate units, and if you hit the chevrons, just about any other type of tolerance method you want. So I select here, I can pick different tolerancing methods and different precisions for them as well. If I show all parameters, it can show me what all my available possible unit precisions and tolerances are. As you can see, each hole note is a little bit unique and you can do just about whatever you want to it. Here I'll choose OK with my global precision selected and no tolerance. I also have the ability to put a quantity note on my files as well. So in the front of my hole note here, I'll put my cursor. I'll hit this pound symbol, which is the quantity note indicator. And this button over here is my ability to edit how the quantity note calculates. So when I click on the quantity note button here, I can have it be the number of holes in a pattern or feature. I'm going to choose the number of holes in view and choose OK. When I say OK to this Edit Hole Note dialog, you will see an 8x appear up here in my hole note. Yes, I could go in there, put text in there, put 8x because I counted up visually that there were 8 holes there, but that doesn't parametrically update. This does. Next up, we'll look at a chamfer note. So I'll choose the chamfer note command from my Feature Notes panel. It wants you to select the beveled edge first and then a reference edge. So here's my first selection and my second selection. Once the chamfer note has been placed, I'm going to choose OK to finish the command. I can go back and modify that note in a very similar manner that I did the hole note command. So here I can say Edit Chamfer Note. I'll get a box that pops up with distance 1 and angle and chamfer. Well, maybe I just want to see CHA and I want that to be capitalized. Maybe I don't want the angle to be shown. I want 2 different distances. So I'll put my cursor behind angle, hit my backspace, and add distance 2 in there. Furthermore, I would like to have a better precision on that beveled edge. So I'll click on my precision and tolerance, turn off my global precision, and for my primary and secondary distances, I'll put on my 3 place decimals. Choosing OK to both dialogues will update my chamfer note. So this has been a look at adding hole notes, thread notes, and chamfer notes to our Inventor drawings. In this video, we're going to examine how to create different types of centerline marking geometry inside of our Inventor drawings. On the Annotate tab, on the Symbols panel, I have a set of 4 centerline and center marking tools. They are located right here on the right-hand side of that panel. Let's begin with a simple one, the Center Mark command. When I select the Center Mark command, I can basically select on any circular edge, and it will give me a center mark on that circular reference, and it will size it appropriately based on proper overshoots beyond our geometry limits. So as an example to that, I'll just select on this hole here, And I can see it creates my center mark with a proper overshoot. And if I select on the one next to it, again, properly sized for that hole with proper overshoots. If I zoom out and do it on the very large circle, again, a very large center mark instead. I'm going to cancel here and undo these 3 center marks. And next, showcase my center pattern tool. When I select on the center pattern tool just next to center mark, it wants me to select a circular reference for my pattern. Here I will choose the center of this machined part, and then I need to pick on additional locations or additional center points around this circle. So I'll begin by doing that on these arcs all the way around. I'm skipping over those because they're not part of my pattern. Once you have them all selected, right-click and choose Create. There I have my centered pattern, at which point I could go back and throw a dimension on there and say that's a bolt circle or a slot circle, whichever way I would like to document that particular centered pattern. I'm going to exit out of the command and then also undo that command. Next up, we'll look at the center line and center line bisector. These 2 commands are very similar to each other, and a lot of people use them inappropriately. Let's begin with the center line tool. The center line tool is designed to go across large center lines. So as an example, maybe I will select right here on this circle, all the way down to this circle, right-click and choose Create. And then here, I can extend that beyond to another circle here. And you can see it just keeps creating center lines and even goes into a curvature if I keep picking on additional points. Let me undo that one. And now I just have that one center line there. I can pick on these green dots and extend them beyond if I so desire. Now, where the center line command fails is when you do short bits of geometry. So if I do center line again, and let's say I choose somewhere down here in this bottom view, I'd like to put some center lines in on these hidden line holes that I have down below. Now, the problem with this is it's hard to tell which ones are slots and which ones are holes, so it becomes very difficult to get my center lines in. Now, if I know without a doubt which lines are part of my holes, when I come in here to try and grab my center points, it does not pick anything up. That's when the centerline bisector really comes in handy. The centerline bisector tool, which is just to the right of the centerline command, allows you to pick on 2 lines and then puts in the bisector between those 2 lines. And as you can see, it gives me a nice center mark there, and life is good. Now if I zoom up here to this area, I can also pick these 2 lines as bisectors. If for some reason your centerline does not give you a long enough line type where you see the dash, you can always grab on the green dots and extend it until you do. Now for those of you wishing to wave a magic wand and just automatically throw in some center lines, have I got a tool for you. Let me zoom out here and just undo all my center lines. This next step, I'm going to hold down my Shift key, select my top view and my bottom view, and then right-click on one of my views. Here, I will get an option for automated center lines. When I choose this command, I can automatically apply center lines to certain pieces of geometry, namely hole features, fillet features, revolved features, and cylindrical features. These last 2 are for sheet metal. I can also apply this to circular and rectangular patterns and both projection methods, so my axis normal and my axis parallel. If I choose OK, I'm going to wave the magic wand and I will get all of my center lines on screen. Now when you have geometry that gets this complex, it might be a good idea to have your center lines be a different color, and that can be controlled by your administrator in your styles and standards. This has been a look at creating center lines inside of Autodesk Inventor. In this video, we're going to examine how to document our Inventor views with symbols. In the Documenting Views with Symbols file from our Working Files directory, I'm going to go to our Annotate tab and look at this Symbols panel. Inside of this Symbols panel is a flyout of multiple different types of symbols. I have user symbols, which are ones we can create ourselves in case Inventor doesn't supply the symbology we need. We have surface texture symbols, welding symbols. We can import AutoCAD blocks as symbols, some welding ones such as caterpillar beads and end fill, and also a bunch of GD&T symbology, such as feature control frames and datum identifiers. I'm going to begin with an easy one, our surface texture symbol. In my lower view, I'm going to find an edge that I would like to attach this symbol to. When I pick on this edge and move my cursor away, it wants me to add a leader to this. Well, I just want it to be directly on that face. So instead of clicking somewhere away from the model, I'm simply going to right-click and say Continue. This will put that surface texture symbol directly onto that face, at which point I can fill this out the way I need to with what type of texture I would like to apply to that face. I'm okay with what I see here for now, just as a reference, and I'll say OK. I'm going to cancel out of the command, and to adjust this symbol, I can grab on the little green dot and pull it away from the model so I can create more of a reference off of that edge to have a surface texture symbol. If I keep pulling on that green dot and I go up or down, I can flip it around and also create the leader. This depends on how you would like to show that. Next up, I'll add a datum identifier to the bottom of this part. I'll click on this edge here, very similar manner to what I did with the surface texture symbol. I can create this identifier coming down off of there, or again, right-click and choose Continue, and it'll apply it to that face. Now with datum targets and identifiers, you do have to fill in what the datum reference is. It doesn't just automatically go from A, B, C, and D. I want this one to be A, so I'll choose OK. I can do the same thing here to pull it off of that edge, just by grabbing on it and pulling it this way. I can flip it up or down, as well as create the leader if I need to. Next up, I'll add a feature control frame to this dimension. So I'll grab my feature control frame symbol. Now, if you're trying to attach something to a dimension, pay close attention to this. When I hover on the dimension, it highlights all my anchor points for that dimension. However, it does not show anything about the text. If I would like this to be attached to the text, I need to move my cursor around the text and I will see additional green dots. Once I see the green dot that I want, namely just below that 3.00 there, I'm going to select with my cursor. Again, I can create a leader coming off here, or simply right-click and say Continue. That will now create that feature control frame so it travels with that dimension. Now inside the feature control frame box, I can choose my different symbology. I can choose my tolerance, my datum targets, the identifier. I can add in my feature control frame controls such as my maximum material, least material, and regardless of feature size, as well as additional notes. For now, I will choose OK, just to showcase how this can move with my dimension text. As you can see, it's following it around. If I grab on the little dot below there, I can pull that off of my text. Again, it just depends how you would like to show this. So this has been a look at documenting with symbols inside of our Inventor drawings. In this video, we're going to see how to place and edit both leaders and text inside of our Inventor drawings. Here inside of our placing and editing leaders and text from our working files directory, I'm going to begin on our Annotate tab on the Text panel with the Text command. Now this command wants you to draw a box that represents the area your text will fit inside of. So I'm going to click and hold and release when I see the rough size that I want to create. The box that comes up next is my Format Text dialog. Here I can choose a different style, as well as justification, stretch, spacing, fonts, sizes, bold, italic, or underline, color, and rotation. Those are all pretty common things we should be aware of from most any other program that does anything with text. Below there, we have a type and property selection. We also have component, source, and parameter and precision. These are a little bit more unique to Inventor. I'm going to begin by typing down here in the box, material, and also mass. What I would like to do is parametrically bring in some of these values, such as material and mass. While I'm currently selected on mass here, I'll go to my type pull down and choose physical properties of the model. And on property, I'll choose the mass property and my precision. The next button is actually very important. This will add this text parameter to my area down below. If I don't do that, whatever I select in those drop-downs doesn't do me any good. For material, this is actually a property of the model, not a physical property of the model. Notice that there is also other items here as well, such as iProperties of the drawing, custom properties from the model, drawing properties, sheet properties, piping styles, and sheet metal properties. For now, I just want properties of the model, and I can pull out the iProperties of this machined part that's been placed into this drawing. Here I want the material, and since it is not a physical property, there is no precision. I still need to click the Add in order to put it down below. Now below that, I have Component, Source, and Parameter. This allows me to look at the machined part, have multiple sources for my parameters, whether they be model parameters or user-created parameters. Now this model didn't have any user parameters, and it really didn't have any important or model parameters I want to track. So for instance, if I just leave model parameters selected in my parameter dropdown, it's just a bunch of placeholder D values, nothing that really stands out to me that is something I want to track. If I wanted to track these values, it probably would have been a better idea to give them a proper name inside of the IPT file. Since I did not, I'm just going to ignore this step. However, if you wanted to bring something in, you select it, you choose your precision, and then there is an input box here with that little D0 on the button. So I'm happy with just material and mass, and I'll select OK. When I zoom in to see what it created, I can see the material is generic and it has a certain mass value to it. If I go back to the model and I update the material, if I update the mass, if I change any of those iProperties that I might have linked in here, they will automatically update parametrically. Now I'm going to create another text box below. And here I'll just start typing in some random text. Notice how the text automatically wrapped down to the next available row. It did that based on the size of the box I had created. If I choose OK, you're going to see that it does wrap inside of here, although it doesn't match exactly to my text box. If I right-click and say OK, that finishes out of the command. When I go back to this piece of text here, I do have green dots around there, to which I can pull and control how that gets wrapped. If I would like to have an explicit carriage return, I can modify the text and just add a return inside of it. So if I double-click my text, that will allow me to modify it. And I would like to have a definitive carriage return just behind the word box. So I'm going to hit backspace just to show that that's still missing the space there. I'll hit return, and now I have a definitive carriage return. By choosing OK, it will obey that. It knows that there is a carriage return there, that I want to have another paragraph. Now, if I would like to line these up, I can go back to both my text boxes, hold down Shift, release Shift, right-click and choose Align. This allows me to align my text, although not permanently. So this is a temporary alignment, just to line things up. I say it's not permanent because I can go back to my text, hover on it, you can see it says move the text location, and I can drag this wherever I want. So that is a temporary alignment. Next up, we'll look at leader text. I'll choose the leader text command, select some geometry on my view to reference off of, choose a point to place the elbow for the leader. Now I only want the one point for my elbow. I could continue to place more elbows in, just one is fine for me. Right-click and choose Continue. This will bring up a very similar text box, and here I can type in what I want to show up. I can do types of properties, I can do component parameters, same thing I did inside the text box. Here I will just type in leader text and choose OK. Now leader text has a unique control to it so that when I move my geometry around just by moving the views, the leader text will always follow with it. The text boxes, however, do not attach themselves to geometry. So a common question I get is, how do I attach just text to a drawing view? Well, you actually do it with leader text. After you've created your text inside that leader, go back to the leader, right-click on it, and tell it to delete the leader. Don't tell it to delete the entire object, just the leader. Now, that leader text looks just like text, and that will float and go with the view wherever it goes. Now, what controls our text styles? Well, we have a styles and standards editor that controls that, and that's something set up by an administrator, but we do have the ability to override these as we're creating our text boxes. This has been a look at the text command and leader text command inside of Autodesk Inventor. In this video, we're going to examine general tables and whole tables inside of our Inventor environment. From the Annotate tab, we have the table panel. Inside of there, we have the general table command, as well as a flyout for multiple whole tables. We're going to begin with the general table command. Starting this tool will ask me if I have a source view to pull data from. In this case, I don't. Views that have that kind of source data are sheet metal views or iPart or iAssembly views. Those are things we do not cover in this course. So for now, my available selections here are to pull from a pull down with nothing in it. The alternative to having something here without a source is I can click on this Browse button. That allows me to browse into my file system and find an Excel file. So if I have an Excel document and I like to have that embedded in here, then I can definitely do so with that little browse icon. Otherwise, this will just be a general table, and I can fill it out with whatever data I want. For now, that will be what I do. So I would like 3 columns and 6 data rows. I'll choose OK and drop in the table. Now when I zoom into this, I can edit that table in any which way I want. I can change the column headings there. I can change the name of the table. I can change the direction that it fills. We do this by right-clicking and choosing Edit. If I would like to change the column headings, just right-click on a column and say Format Column. Here I can put in a new column header, as well as adjust the width and justification. If I fill out data here, I can do so just by filling in cells like Microsoft Excel. If I would like to change the way the table is laid out, I can right-click in here and choose Table Layout. Give it a new name. Adjust its heading, also its text styles that it utilizes, and its directional fill. So I'm going to adjust my heading to be on the bottom side and fill my direction going from the bottom up. I also have the ability to control table wrapping. For now, I will say OK. Nothing here changes. The other items I have up here at the top are a column chooser, where I can bring in columns. Nothing really to do here. These are all just basic empty columns with no source material, but I can choose new column down there. Also adjust them by move up and move down. I'll go ahead and cancel out of there. I also have a sorting utility, an export utility. There's my table layout button if I rather choose it there rather than right-clicking, and also inserting and removing rows. I'll choose OK here, and we'll see my format changes as they took place. I'm going to delete this table by selecting on it and choosing my delete key. Next up, let's look at our whole tables. If I go to that flyout, I can do a whole table based on selection, based on the entire view, or based on selectable features. Now, I'm going to do this based on my view because I have a lot of holes. I just don't want to go through and pick them all. I'll choose the second method. I'll pick my view and select an origin location, in this case, the very center of this machined part. Once I have done that, it then automatically generates a table of all the holes that I have here. I'll go ahead and drop it in, and what it has given me is all these labelings for my different holes, as well as a chart of that hole and its X and Y dimension based off that origin, and the description of that hole. Now, there are some holes here that I don't really want to call out, such as the E1 hole, the F1, the G1 hole, and that's an easy thing to fix. I can right-click on a table and go to its row and tell it to delete the hole. It will automatically roll up my table based on where I right-clicked to get rid of those holes. And it also gets rid of it as far as my documentation in my view as well. Now, I would also like to group my descriptions together. So if I right-click on my table and choose the command called Edit Whole Table, I can do a row merge setting to do different types of merging based on numberings, reformatting based on custom hole matches, do different roll-ups, different combines of notes. I can also change my tag order to be based on size rather than position. And on my first tab up here, I have all my formatting tools that I'm accustomed to have with my tables. So I can adjust my heading as well as different columns I might want to appear, such as counter bores and counter depths. If I scroll down a little bit further, also X and Y alt dimensions. So if I have millimeters and inches, I can show both. For now, I'm happy with what I have there, and I'll go back to my Options tab. Here I will tell it to combine my notes, and I want to do this based on numbering. When I choose Apply, I can see a preview of that taking place. So now I have holes 1 through 19, the X and Y dims, and I have combined descriptions, so I don't have all those extra description lines. I'm happy with that, and I'll choose OK. Now in my actual view, if I'm having a hard time with my numbers crossing over object lines, anything of that sort, or they're just too close perhaps, I can click on my number and hold and pull off from there to get a leader. So this has been a look at general tables as well as whole tables inside of Autodesk Inventor. In this video, we're going to look at revision tables and tags inside of our drawing environment. From the revision tables and tags, DWG, from our working files directory, on the Annotate tab, on the table panel, I'm going to go to our revision flyout up here. The first command is a revision table. The second command is a revision tag based on different revision rows that we have. To begin, I will select the revision command. This command will ask me if I want to do a revision table for the entire drawing or just the active sheet, as well as what my index will be for that revisional scheme. I'm going to choose numeric to begin with a value of 1 to start off. The bottom selection, Update Property on Revision Number Edit, refers to the I property inside of the drawing environment. I'll choose OK. And now I need to drop the table in. Normally, people will put the table in the upper right, or perhaps right above the title block, depending on what they prefer. Here, I will choose the upper right area. When I zoom in, I can see I have multiple columns, such as a zone, which refers to my areas around the border for zone detailing, revision, description, date, and the approval. Now, where did it get that description from? Well, it got that description from some of my I properties. If I go to my Revision Tables and Tags, DWG, in my model browser, and right-click on it, select I properties. On the Summary tab, you'll see a comments field called Another Hole was added. On the project, I will see revision number 1 has been filled in. I'm going to close this, and let's imagine that we have a new revision to our design. In order to add a new revision row, simply right-click on the table and select it from your menu. It opens a box up and lets us know our current revision, the description, date, and approval. Here it allows me to modify my different cells inside of this table. However, any modification done here is not a parametric update. It's basically a table override. Instead of changing the values here, such as revision, description, date, and approval, I will do that in the I properties. The only thing I feel comfortable changing here might be the zone in which the revision takes place. If I would like additional rows, such as an ECN process or an engineering change number, and add that column, I can do that with the column chooser in the upper left area of this dialog. For now, I'll choose OK. If I examine my I properties again, on the Project tab, I will notice my revision number is now number 2. On Summary, I need to change my comments for this description. I'll choose OK, and we'll see our description in the revision history update for us. If I right-click on the revision table and select Edit, and choose the Table Layout button, this allows me to control headings, text styles, as well as the title of the revision table. Our next step is to add a revision tag to locate where our revision took place. By choosing the revision tag from the flyout, we can place this in a very similar manner to any symbol we have in this environment. Here I will just select the machined part, geometry, right-click and say Continue to finish placing the leader. Let's say this was actually revision 1. If I right-click on that tag and go to the tag flyout, I can change it to the other revision, number 1. So this has been a look at how to create revision tables and tags inside of Autodesk Inventor.